Okay, hello everybody. My name is Lindsey Nowland. I am currently working on my PhD at Old Dominion University in Norfolk, Virginia. And I'm going to be talking to you guys about independent and dependent variables, as well as descriptive statistics. If you have any lingering questions after watching this video, feel free to shoot me an email. My email address is right here on the first slide. I'll do my best at trying to answer any of the questions you may have. But I also recommend checking out the text that I referenced at the end of this slide, especially the one on statistics for people who think they hate statistics. It's a very easy read and it puts things in layman's terms for us non-statistics people to understand. So there are, to start off, we're just going to talk about two main types of variables: your independent variable, otherwise known as your predictor variable or your explanatory variable, and your dependent variable, also known as your outcome variable or your response variable. Now, independent and dependent variables are typically used in experimental research. However, they are in every research study. It does not have to be an experiment to have your independent and dependent variables. They're just easier to identify when you're conducting an experiment. So the independent variable, this is the one that you, as the researcher conducting the study, changes or enacts in order to do your experiment. So the independent variable is not affected by the experiment itself, but it can be manipulated to affect the dependent variable. So it causes or predicts another outcome or the outcome of the dependent variable. It does not depend on any other variable, so therefore it is independent of all other variables. That's your key reminder. It does not depend on any other variables, therefore it is independent. It is a variable that you, as the researcher, can control in your study. So there are two main types of independent variables. You have your experimental independent variable, the one that is used in an experimental research study. This is the variable that is directly manipulated by the researcher to see how this variable affects your dependent variable or how it affects the outcome of your study. It's typically applied at different levels. So different amount of time spent during physical activity. You might have different groups in your experiment, and each group gets a different level of physical activity or teaching strategy. Whereas the subject variable, which is usually used in your non-experimental studies, the subject variable refers to the characteristics that vary across participants. So their gender identity, their race, their income, education level. This is the variable that you might be looking at how one's gender affects their participation rates in physical activity. So your independent variable is just gender, for instance, in that example. So your dependent variable, on the other hand, is what changes when the independent variable changes. So it depends on the independent variable. The outcome of your study depends on the predictor or the independent variable that you are manipulating in your study. So the dependent variable is what is being measured, what you actually want to find out. It's linked to the primary outcome of the study, and it's a variable that you can easily observe or measure within any type of design. So again, the independent variable causes the effect. The independent variable causes the dependent variable or causes the effect of the dependent variable. It can be manipulated, whereas the dependent variable is measured. So if you're manipulating different levels of the independent variable, you're measuring the outcome of those different levels that you've manipulated. So an easy way to identify your variables is by just asking yourself, is the variable manipulated by the researcher? Has the researcher changed the amount of time spent in this variable or the level of dosage a participant is receiving? If the researcher manipulated the amount of the variable, then it is the independent variable. Whereas if the variable causes an outcome, if it can affect something, if it can impact something, it can cause something, that is the independent variable. So the variable where the result is based off of another variable. So the outcome is influenced by the amount of something or the effect of something. If it's affected by something, then you have the dependent variable. So if the result, or if this variable is a result of another variable, it is the dependent variable. So just to break this down with a couple research questions that I've created here. So what is the effect of teaching strategies on student achievement? So if I'm reading this question, I'm looking at the effect of teaching strategies on student achievement. An easy way to rearrange this type of question or to identify your variables is to set up a hypothesis. So if you hypothesize, I hypothesize that a teaching strategy, if you have 3 levels of teaching strategies, will level 1, I hypothesize that level 1 will have this sort of effect on student achievement. If you rearrange the language within the research question, asking yourself what is causing the outcome, you can easily identify the variables. So teaching strategies effect on student achievement. I'm looking at how teaching strategies affect student achievement. I can manipulate the type of teaching strategies that the participants might engage in this study. I can change the how many teaching strategies each participant is being given and things of that nature. So if I can manipulate the teaching strategies is the independent variable. Whereas the outcome of the study, so I'm looking at how teaching strategies affect student achievement. So I'm looking at the outcome of student achievement. Therefore, student achievement depends on the type of teaching strategy. Another one here is, how does the amount of physical activity participation affect individual body satisfaction? In this case, the word affect is in between the 2 variables, setting up you for an easier chance of identifying the variables. So the amount of physical activity, I can change that. As a researcher, I can manipulate the different amounts of physical activity that students might engage in. But I can't manipulate someone's individual body satisfaction. That's their own. That's based off of how much physical activity participation they engage in. So in this sense, the amount of physical activity participation would be your predictor variable, the one that you can manipulate in the study. Whereas individual body satisfaction depends on the amount of physical activity participation one engages in. So the last one here, how does phone use before bed affect sleep time? This question is, it leaves it open to the reader's interpretation. In this sense, I might go look at the hypothesis to know in what type of phone use is the researcher looking for right here. Are they looking at the amount of sleep time, or are they looking at quality of sleep time? If there's not a hypothesis given, give your own hypothesis. You can create your own by saying the more sleep time or the more phone usage might affect the amount of sleep time that I get, or the amount of sleep that I get. So in this sense, The amount of phone use would be the independent variable, because I can change that as the researcher. I can manipulate how much time someone spends on their phone. But I can't manipulate how much time they sleep. That is all predicted on the amount of phone use they have. So again, an easy way to identify your independent and dependent variables is to provide yourself with a hypothesis of the question. Create yourself a hypothesis, which will easily show you what is being predicted and what is the outcome, or what is being measured in this study. So when you're graphing independent and dependent variables, this is very common within the actual write-up of your study. You might provide some sort of visual graph to display how your independent variable affected your dependent variable. I have provided a simple line graph here, but to provide context, the independent variable, or the predictor variable, is always on the x-axis. So it's always on the bottom, the ground level, or the foundation, whereas the dependent variable is always on the y-axis. It doesn't matter what type of graph you're using. If you're using a bar graph or any sort of graph, the y-axis always includes the dependent variable, whereas the x-axis has the independent variable. An easy way to remember this is that you have to lay the foundation before you can build the building, right? So you have to provide the predictor before you can receive the outcome. So in this sense, by placing that independent variable on the bottom, you're laying the foundation. You're laying the foundation of your study. And then to build that building going up depends on that foundation, depends on the base level that you've applied. So that's just an easy way that I've used to remember where to plot the variables on a graph. And also, if I describe this line graph right here, the x-axis, or the independent variable, you can see here, as the independent variable goes up, the dependent variable is manipulated, or the outcome of the dependent variable depends on the different points of the independent variable. So we'll talk about graphs a little bit more. But so descriptive statistics, your independent and dependent variables are key indicators within your descriptive statistics. They tell you what you're going to describe, or what is going to be included in your descriptive statistics portion of your results. So again, the descriptive statistics are used to summarize the data without making any inferences. So you're not looking at how the independent variable affected the dependent variable yet. You're just looking at the information that's already present in the data. So descriptive statistics are used to organize and summarize the data that's already presented, that's already been given to you, without applying the independent variable to the dependent variable, or without looking at that effect. So you're just calculating proportions and percentages. So with descriptive statistics, you're describing the population that is being studied. The most common ways that descriptive statistics are reported are by using your measures of central tendency, so your mean, median, and mode, and your measures of variability. You got your range and your standard deviation, and then frequencies, or frequency distributions, which are your charts and your graphs that display the frequencies of things like participants' age or their gender. Maybe it could be their type of disability. It all depends on what you're looking at, but you're describing the frequency of the participants within the study. So breaking down the different parts of your descriptive statistics, your measures of central tendency include your mean, also known as the average of all scores in a distribution. So it's the sum of all scores divided by the number of all scores. The mean is the most commonly reported measure of central tendency within the descriptive statistics. It might look at the average age of your participants or the average participation, physical activity participation levels. If I use the phone usage example that we talked about earlier, you might report here in your descriptive statistics the average amount of time that participants reported spending on their devices before bed. Or you might report their average amount of sleep time that they get, but you're not making any inferences on whether their amount of sleep had anything to do with the amount of time that they were spending on their phones. You're just describing the data. So your median is the middle score in the ordered distribution. So 1/2 of the scores are above this number and 1/2 are below this number. So in this case, you'll line up all your scores. It could be from largest to smallest or vice versa. They have to be in numerical order though. And then the median is the score that falls directly in the middle. An example of this might be the median income level of the population that you're studying, or the median education level, things of that nature. It's not as commonly reported as the mean, but it is still included. And as the researcher, you will be collecting this data. You might not be writing it up in your results, but you will be collecting it to help you describe your own population. So the mode is the single most common score in a data set. So you might plot all of your data or all of your different data points, and you're just counting how many times the score 25, for example, came up. How many participants reported 25 years old? How many participants reported 17 years old? Things of that nature. So the most commonly reported score in the data set. So your measures of variability, on the other hand, include your range, or which is referred to the difference between the highest and lowest score in the data set. In this case, you might take the biggest number and subtract the smallest number from it to give you your range. So taking participants' age, for example, you might subtract, if the oldest participant is 70 and the youngest participant is 16, subtract 16 from 70, and there's your range, your age range. Again, the larger the range, the greater the number is in your range, equals a higher variability. So in that case, you would have the age of your participants would vary. Yeah. So your standard deviation is the average deviation from the mean. This is the amount of variation or dispersion of a set of values. So if the average age of your participants was 25, your standard deviation might be 1.25, which just means that on average, your participants deviate from the mean by 1.25. So you're on average, your mean age is 25, and on average, the participants' age vary from 25 by a year and a quarter, or less than a year and a quarter. So for frequency distributions, again, frequency distributions is a table or graph that shows how often different numbers or scores appear in a particular data set. Some common examples that you might see are histograms, which is a bar graph that shows your frequency distribution, or a polygon. It's a line graph, just like the one that I showed you guys earlier, that displays your frequency distribution. So in this case, you're calculating the frequencies of your data set. So how many of each score is there in the sample of data? So simply order the scores from smallest to biggest and count the number of each score. Those scores can then be arranged into a frequency distribution. So just remember, frequency distribution refers to the actual graph or table of your that displays the frequencies of your participants. So I have a couple examples here. If you look to the far left, I have a table here of the glasses of H2O. So how many glasses of water did the participants drink? And then on the right, I'm calculating the number of people that drank that many glasses. So I'm just doing simple addition, going through the data set and seeing, okay, how many people had 2 glasses of water? 1. How many people had 3 glasses of water? 2 people did. And then so forth, going down the table. So once you have your table created, it provides you an easy visual for you to see maybe the most common amount of water that your participants drank. So in this case, you can see by the histogram and the polygon, what they've done here was plotted the independent variable, or the glasses of H2O. How many glasses of H2O did someone drink, along the x-axis down here at the bottom. And the number of participants was plotted in numerical order along the y-axis. And once you have your table created, it's a lot easier to create these graphs by looking here. You can see 6 people, or 6 glasses of water had the most people drank 6 glasses of water, which was 6. 6 people drank 6 glasses of water. And your polygon is the exact same thing, your line graph. You can take this line and put it right on over top of this bar graph, and it makes the same exact shape. It's just another way of displaying your data to your readers. So some examples of what goes into descriptive statistics. Remember, descriptive statistics, you are describing the sample of data without making any inferences. So it doesn't even matter the effect or the impact of your independent variable on your dependent variable. You're not looking at the way that independent variable may influence your dependent variable. You're just describing the variables in their whole form in the data that's already presented. So the proportion of students who completed their program of study at X community college is 0.45. This is just an example that I've come up with, but this is something that you might talk about when you are describing your data. So you can easily make this decimal into a percentage by timesing it by 100, or just moving the decimal over 2 places. So 45% of students completed their program of study at whatever community college in this example. Another example, you might talk about the average age of the sample was 15 years old, which also means the mean of the sample was 15 years old. The median household income was 30,000, and the sample was 52% female. So some more examples of what goes into descriptive statistics. I am working on a study right now where I'm looking at how does meeting 24-hour movement guidelines, so how does meeting these physical activity guidelines impact anxiety and depression among children receiving special education services in the US. In this example, or in this study, it's a working study, but we used an already provided national data set of students receiving special education services. And we were just looking at their reported movement time spent in their movement guidelines and their anxiety and depression levels. So independent and dependent variables, in this case, this is not an experimental study. So this is an example of how independent and dependent variables can be applied to non-experimental studies. In this case, we were looking at how does the physical activity guidelines impact anxiety levels and depression, but we're not manipulating these 24-hour movement guidelines. We're not changing them. There are subject variables. That's the type of independent variable it is. It's what the subjects already reported. But that had those reported numbers impact their anxiety and depression levels. That's the inferences that we're making. So dependent variable, anxiety and depression, depends on the amount of time or meeting those 24-hour movement guidelines. Let me just get to the descriptive statistics that I wrote up. It will provide a better example. So the first two paragraphs of your results section in your study will talk about your descriptive statistics. This is the first thing that you are going to present to the readers so that they can get an idea of your population, of your participants, and the different thing, or it could be their age, their gender, ethnicity, things of that nature. So if we take a look, again, we used a national data set. So this data set yielded, or it provided us 5,802 children. So the amount of children, describing the amount of children from 6 to 17 years old. There's my age range right there, that were receiving special education services in the United States and who completed the data of the studied variables. So as shown in table 1, we created a table that displayed the information that I'm going to discuss here. So the mean age of these 5,802 children was 12.03 years old, plus or minus 3.35. So this plus or minus provides or tells you that this 3.35 is the standard deviation. So the range of my participants, the age range was 6 to 17. However, the average age was 12.03 years. So on average, the participants were 12.03 years old and plus or minus 3.5 years. And they were 33.7% female. So I'm describing the percentage of gender identified in this participant pool. Ethnically, the sample consisted of 51.8% white or non-Hispanic, 22.5% Hispanic, 16.8% Black or non-Hispanic, 7% other or multiracial, and 1.9% Asian. So I am describing the participants' ethnicity. This did not make any inference. Their ethnicity did not depend on any other variables within the study. It's just describing what's already present in my data. The participants were relatively equally distributed among 4 household income brackets based on federal poverty level percentiles. And a majority of the participants' parents, 60.1%, reported one or more adverse childhood experiences. So you can see by taking a look at this first paragraph alone, I've described the age, or I've described the amount of participants in the study, the age range, plus the mean and standard deviation of the age of my participants. I've described how many were female, or how many, I've described the gender of the participants. And I've described the ethnicity, poverty level, and childhood experiences, all with percentiles and means and standard deviations. So the second paragraph, you can see it's going to get more closely tied with the variables that I'm looking at in this particular study, but I'm not drawing any inferences. I am describing the reported depression and anxiety levels and physical activity levels, but I'm not calculating how meeting those physical activity levels affected their depression or reported anxiety. I'm just describing what they reported. So 8% of the participants reported having depression with a 95% confidence interval. This you'll talk about later in further statistic courses, but typically you always use a 95% confidence interval. That is out of the scope of descriptive statistics right now, but 18.8% reported having anxiety. So 8% of the participants have depression, 18.8 have anxiety. Up front, that's just what was reported. It wasn't based on any other variables. It wasn't based on their amount of physical activity levels. That's just what they reported. So looking at each movement guideline independently, we found that a large portion of children did not meet the physical activity or screen time viewing. So 78.6% of the participants in the study did not meet the physical activity guideline, and 58% did not meet the screen time guideline. However, 78.3% met the sleep time. So 78.3% of the population is getting a good amount of sleep, according to the 24-hour movement guidelines. So the estimated percentages of meeting none, 1, 2, or 3 of the 24-hour movement guidelines among children receiving special education services are presented in Table 1. And overall, 10.3% of the sample met all 3 guidelines, 33.8% met 2 guidelines, 43.1% met 1 guideline, and 12.8% did not meet any guidelines. So with this second paragraph, I have described their levels of depression, I've described their reported anxiety, and I've described their reported 24-hour movement guidelines. But I have not looked at how those movement guidelines have affected their depression or anxiety levels. That's for a later time when you're working on inferential statistics. But in this case, descriptive statistics, you are just describing what's already present within the data. So I really hope this helped with your understanding of independent and dependent variables, as well as your descriptive statistics. And again, I encourage you all to reach out, ask me any questions you might have, and check out these textbooks, specifically statistics for people who think they hate statistics. It is user-friendly and it provides examples of how to write up and where do you pull that descriptive statistics information from. And the Rutledge Handbook of Adapted Physical Education. There are also many chapters in there. There's one specifically to reporting measurements in adapted physical education research. I encourage you to check out both of these textbooks. They provide great information, and feel free to reach out if you have any questions. Thank you for your time, and I hope I helped in your understanding.